Welcome back to another video. In the last video we looked at components and soldered them up on the new board. And in this video we are going to check the placement in the case. We're going to salvage some parts from another board and put them in this computer and turn it on. Also we're going to do some adjustments to the layout. Just want to thank the sponsor of these boards, PCB. So I mounted this bracket thing. And I'm happy with that because everything is fitting so nicely. The switch is new, and let's talk a little bit about that. The new one which I bought was sitting too high, which has this stand underneath it. So I just broke that off. It has 6 solder connections, so it kinda, when you push it here, you press on the solder connections, but yeah, almost the same maybe.
Og jeg var administrerende direktør. Ja. Ja, men nå har vi jo ordnet også pensjonen, så nå dette blir bra. Ja. Vi har ordnet oss nå. Å ja. 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 Så flott. Ja.
So it's April the 25th and it's morning. Okay, we have it at 341, that's a bit high. I will set it to... You may notice I have the same soldering station that Tommy has and Arctic Rector, but I don't have any beep sounds because I desoldered it. Because I was a bit annoyed by the beeping. Now if you look closely, this is where I started and this is where it ended. So you saw me adding flux late in the process. Well, you can see these guys didn't have flux on them, so you can see So here we have the original board and we are going to check the placement in an enclosure. So here we have a couple of disk drives, we have the power supply I made a couple of years ago. This is coming up in another project. Yeah. So I have the bread bin. I won't bother put the machine in that one. We have a replica C64C. This one I know has a wrong position of the mounting holes. Something must have gone wrong in the production. We have talked about that before. This is my original C64C, which is called. But I will try with this one, and also the C64G, which I'll show you in a moment. And here we have a keyboard prototype. I have 2 of those left. I actually got 5. So I'll probably hang this on the wall. I'm really happy about this. It's with gold and everything. So yes, here's my pretty C64C. And this one is really pretty because it's been kept in a box for so many years with the plastic on. And it was almost not used and everything. So first off, the most easiest one, because I already took out the board from that computer. So yeah, so here we go. Alright, it's actually as if it just clicks into place. I don't know why. So this is good. It was very good on this side. I had to make this is good, yeah. So let's move on to the side, which I know is a bit off, as you can see. Which is something we saw in the scanned image also. So, do you remember in my first video, I stretched only this part of the image to make all these sockets fall onto the grid. I will try to measure how much I need to move it in. We also need to make sure that this board sits very good here. Maybe it should be a bit more tighter over there. Yeah, this is my own machine. You've seen in my early videos with the SD to ISC. Oh, I really love this. I haven't used this in a very long time anyway. And then this one, just try to keep tabs on how everything was fitted. Oh yeah, this was my... yeah, look at this crusty connection. Oh, there comes the whole connector. And we see we have some space between the ports there, and unfortunately I don't have the switch on here right now. So now I just want to check some voltages and look for a short circuit. Try not to put in any of the MOS chips anyway. I have some chips in here, but I think they will be okay. So I have a power supply with a voltmeter and a current meter, so I can watch that. And I have my C64 saver with an add-on board, and the add-on board is capable of measuring current. So let's turn it on. You can see it draws a little bit of current. That's a good sign. So you can also see here, if I turn it off, turn it on. So this is good. Now the reason why I made this one is it wasn't so much for saving the Commodore 64. Well, it can do that also. The add-on board was more for testing and stuff, so I can watch on a meter. And also, if something is wrong, like a short circuit, I will show that in a moment. So what you can do is you can go into setting, you can set overcurrent, you can set hold if there's a over voltage. You can set trip point. So there's already a trip point for the saver, but you can set a second trip point. Okay, so I want the lowest current I can get for it to stop. Because now I'm going to short out the computer. So there you go. Now we have overcurrent at half. Alright, so let's see what happens. I haven't tried this before. And 6. I hope I don't break the socket when I do this. Anyway, I'm gonna turn it on, see what happens. Oh, look, it blinks. This is a good thing. Now it's actually doing its job. That means it saw 1.3 amps and then it cut the power. And you can see on the power supply, it's actually not supplying. Oh, there it supplies a lot of current and then it stops. So this is what I mean by fault finding with the add-on board on the C64 saver. Can be quite handy, I think. So I'm going to turn this off. and then this should stop blinking after a while. There you can go. I just wanted to show you that, so it was a bit fun. I haven't actually tested that yet, so there you go. Hope you found that interesting. So there's a couple of videos coming up regarding the saver, which I have neglected for like 3 years. So this one, which is completely new, which is called the OCP. It's the C64C saver. So this is like the old one, and it's an updated version. And this update has a few modifications to it. And the OCP, I made this because the add-on board is quite difficult to make, actually. And I felt that I was designing myself up in a corner with that add-on thing, because it takes a lot of space. So what I did is that I made a design, which I haven't tested yet, but this has a saver and overcurrent on the same board. And it's a max chip. It has a comparator with latch, so that means if there's an overcurrent, it will latch on, turn off the output. And now it's nothing to do with the Robocop, it just says OCP, which means overcurrent protection. Anyway, so yeah, so that will be upcoming video, and I hope maybe this will be easier to make for people than that add-on board thing. This is my private repo at GitHub, and here I have the board for now, so I could cooperate with Tommy. And so this is the image that I've been working on, and I got it on the net, and I'm not sure who made it. I will just link it in the description. And I was saying that was something about the scanner that made it bad on each side, so I had to stretch it a little bit. Well, now something doesn't make so much sense anymore. For example, if I look up here, it looks a bit slanted. And if you look very closely, this is not a typical image from a scanner, because you can see the holes, right? But you can see the sides of one of the sides of the holes. So you have parallaxing. So parallaxing is like when you have everything on a line, and then you move to the side. None of them are on kind of not on the line anymore for you. So this is the same here. So basically they had a camera in the center. So if you find a hole in the center like this one, you can't see the sides anymore, right? And if I go to the outer one, yeah, now you can see the side wall again. So let's have a look at an image that I scanned at work. This was really horrible to work with, this image. But that's another point. So let's have a look at the holes. So this is the KU motherboard. I scanned it, so I know. And you can see there's no parallaxing here. Maybe you can see some of the top there, but it's consistent for all the holes. So let's go to the center, looks good. Let's go to the outer one, looks good. And that's what you get when you scan, because when you scan you are on top of the image at all times, right? You're not on the side looking from the side anymore. So I believe that this image here has been taken with a camera. So that's why it's not perfect. As I said in one of my earlier updates, update 1 or something, I said something that, well, if you use a camera, then you're a genius. But if you use a scanner, it's much easier or something like that. We use the center hole as a reference for all the other holes. And the center hole might be incorrect, but since we have a photo, we should be able to use a photo to perfect that as well. Alright, so there it is. Now let's make some measurements. This is not bad, but I will subtract or move this one. That looks a lot better, but we still have something wrong here. The height is wrong. That's perfect. This looks already really good. So let's keep that. And let's move to the next holes, which is here. Alright, so we'll move it 80. This is looking perfect. 91446. I think I will do the upper hole first, because it's the mounting post. Okay, so I'll move this one. This is close enough, and then we will get it down to 12. The most important here is the mounting posts. So for these two at the bottom here, I will just reuse the ruler instead, because I don't have any reference to it in this design. So okay, so let's address the problems we saw in the motherboard with the crystal and the joystick ports. So here we go. So what I've done here is that I've just put vias. So it's a bit lazy of me, because vias don't have anything to solder to. We can also look at the back. We need some pads. So let's fix it. So let's just edit library footprint. Let's place these guys, which is ground. I'm gonna increase to 2.4 millimeter, and then I'm also gonna have one here. I'm not sure exactly about the placement. This looks already much better. Then we're just gonna update the footprint from library. Yeah, dead center. They are happy with that. Just gonna delete all the vias that I had. And now we should be done. Look, now we have places to solder to. So that's good. Now we can also look at the back side. Yes, now we can also solder on the back side. And also, luckily, I'm not hitting any of the wires on the back here. Now for the joystick ports, let's have a quick look at the 3D there. Right. So you can already see that this is a mechanical hole, and it doesn't have a true hole plating. Like this, and do a true hole. Right, so it doesn't want to do that actually, so the reason is that you need to do true hole, and you have to increase the diameter. Let's update footprint. So now this one has a true hole plating, but the other one doesn't, and we also see there's a ring around here. This is because this is not electrically connected to ground, and it doesn't do that in the schematic either. So I think we can double click it, and could there be somewhere here we can connect it to ground? It's not, it's a bit hacky. Probably we'll get some errors if I run the DRC now, but oh, it's still not filled. Why is that? Do I need to press B maybe? Yeah, so that's good. Now we are in business. This is what I wanted to see. This is the anchor that you solder to, and in the front here you can see there are metal, and this metal is connected to that anchor. So that means when that is soldered, the ground will also come out in the front there, which is a good thing. Right, so let's have a look at the motherboard and make some measurements. Before we put in the chips, I want to be safe before I put in these MOS chips. So what we want to see is the correct 5 volt on the correct place. And the Xenon diodes, I made a mistake when I made the KU or 254.7 replica, I don't remember anymore, but I mixed up the Xenon diodes. So you're going to check this one, which is regulated power to the SID chip. And we're going to check this one, which goes to the cassette port. And yeah, so this is because with that you will need 9.6 volt actually. The cassette port, and here we see a Xenon output 6.8. Let's see. 9.5. It's pretty good. That's pretty close to 9.6 anyway, so let's have a check on the SID port here. 28. Yeah, 9.1. Alright, so that's probably correct because it's supposed to be 9 volts, so as you can see here, 9 or 12 volts. So that's good. Okay, let's go to the 5 volt, which is supposed to be here. We see 5 volts, so that's good. Let's have a look at the Xenon for the cassette port, which is supposed to be 6.8. This is acceptable, which goes in on the base, which is good. The unregulated is here on the collector, which is pretty high, but when you start inserting chips, it will go down. So I'm pretty happy about this. Look what I found. This is something I had in storage for a while. So it's called a magic desk. So I'm just looking for some cartridges to have the dead test on. So that's good. This is what I've been searching for a couple of days, and it happened to be just right next to that red thing there. So yeah, very happy to have this now. Right, so soldering the video modulator replacement, and I was wondering about the grounding connection up in the corner. The shortboard, you don't need it anyway. So, and then I read the schematic, and it was a bit hard to follow actually. So you see the flow here, it's not so obvious, but if you read everything, then you can see it. It's like inputs and then outputs up here. I'll just do a short time-lapse just to show you what I mean with a better schematic. So here's the schematic now, and I changed everything to A4 format. I have made a flow from left to right. I have collected everything that has to do with the input in dashed boxes. But that was one problem I had, was that this grounding input, do I really need to connect it? I don't know. Is it for the short board? Is it for the long board? Now that everything is collected like this, you can see that for long board you need a grounding. I already know this from before. I used to do this 254.7, like I connected this one, and then you see we have the grounding pin here, I think.
Alright, so we are ready to insert chips now, and yeah, I also found these two here. Well, these are joystick port protection, ESD protection devices. This has castellated holes, and then you solder it in place, and that's it. They have special diodes, and they are used for protecting against ESD. Let's start plugging ICs, and I have been cleaning these up as you saw earlier in the video. And yes, it's just gonna start plugging them, and we probably need to try and straighten some pins, but since they came straight out of the computer, I think they will be good. So oh, there's one pin bending there. So yeah, I'll just pause. CPU U6. There you go, U6. We have the CPU. There you go. Now let's find 6126, another CIA. I think this one goes over here. Oh, there you go. What more do we have? We have the VIC chip 8565, which is U7. So here we have a U7. You can see that all chips are good. There you go. Oh, nice sockets, by the way. Then we have the large one, which I saw in the other video. I think Arctic Retro was struggling a bit with this, so I will try to do my best as well, because this was a bit hard to insert. I think these pins needs to be really perfect and everything for it to work. And I've been desoldering really much. There's no tagging or hooks. If there are, it could make problems. So yeah, so let's try this. Let's see if we can line it up. At least on this side. Yeah, it seems to be lining up there. Now the other side. Yeah, it seems to work well. Because when I start using force on this, yeah, look. Yeah, that's what happens then. So yeah, so all of the other ones are good. Yeah, so this pin keeps bending, so I don't know what it is. Need to figure this out. We don't want to break it. This is the only pin we got. Okay, let's put those in first, make sure that it doesn't break again. So let's force it down now. Yeah, it's in. That was a bit hard actually. Let's give you a close-up. So now they are good. Yeah, looks good as well. So I keep forgetting how close we are to a final setup. So actually I wanted to put in a room that was original, but I didn't find it, so I guess I will use the kernel switcher. So it's in. Now we actually just gonna connect power and the screen and try it. That will be very exciting. Let's connect power. Let's turn on the power here. Oops. Then we have connected the C64 Prototype into here. First you need to just get down to, I don't remember, I think it was S video. And this cable in the side here is pretty bad, so, but here goes. Anything at all? No signal. So is anything getting hot? Oh, I don't have RAM. I was a bit quick. Yeah, well, I have RAM, but I don't have both of them. So that's unfortunate. I have to wait for that. Also, I need color RAM. Yeah, I forgot that. I was a bit excited for this. Yeah, so yeah, I think I will end the video there. I'm sorry about that, but also the fault finding for getting this to work will also be done in the next video, also for Arctic Retro. So that makes 3 videos, and that will also be better for me as well. We have the same pacing. So thank you so much for watching, and see you next time.